This video is to demonstrate the functionality of the Great Lakes Watershed Management System online mapping tool in support of the Improving Stream Habitat in the Maple River Watershed program, which is an NRCS RCPP project administered by the Institute of Water Research at Michigan State University. My name is Glenn O'Neill. I work at the Institute of Water Research, and I'm going to be presenting this first of several videos, tutorials, describing how to utilize the Great Lakes Watershed Management System as part of the screening process for that project. This first video, I'm going to cover several topics, mainly how to navigate the system, how to utilize some of the basic tools and functions, and how to use the score calculator to get a result for a particular field that you wanted to evaluate. Subsequent videos will talk about how to do batch simulations on large numbers of fields and how to generate reports. But this first video will focus on the basics of how to navigate the site and how to generate a score result for a single field. So the system is organized into a series of buttons at the top of this toolbar up here. I'm not going to go over all of them right now, but I do want to point out some of the features. The first is the Map Layers button on the top here. And if I click on that, it'll open up a sidebar. And under this General Layers tab, it'll give me a couple different map layers that I can turn on and off. The ones of most interest to this project are the Priority Areas layer, which I can turn on here. The areas in blue are areas for which this project is seeking to enhance groundwater recharge. And the areas in green are areas where the primary focus is on reducing sediment loading to streams. You can click on the Identify button for any of these map layers to get more information about them. But this particular layer, the priority area, will come into play when calculating a score, because different criteria will be utilized to evaluate a field based off whether that field is located in a blue area or a green area. Now, I'll demonstrate some of that in a couple minutes when I do a simulation here. You can turn these off and close this sidebar to see the full screen just by clicking on that. I'll point out a few other functions with the map. There is a navigation button here where you can type in an address or a PLSS, I should say, value if you have one. But it's just simply typing in an address and clicking the search button, and it will zoom into that particular location. You can also just use your scroll wheel on your mouse if you have it, or the zoom controls that we have here in the upper left-hand corner. We'll do that to demonstrate how to generate a score for the RCPP project. So we'll zoom in, and it's usually easier to stick with this street map as a reference point when looking at that scale. But as you get closer to a particular field of interest, you'll probably want to switch to base maps, which you can do here. And there are a couple different options here. We'll go with just the imagery option here. And if you have if you're curious at all as to when a particular date, when a particular image was captured, there is an image date button here that you can click. And it's going to tell me to zoom in to get a specific look. So this particular image was captured on October 12th, 2016. Sometimes that's a topic of interest when people are looking at aerial imagery of a particular area, so you can pull that up through the system here. But let me zoom out a bit. So you can toggle between aerial photography. Sometimes it's more useful to have the roads on there, so you have that option as well. I'll point out another map layer. Since this project does deal with sedimentation to streams, we do have a map layer that identifies areas within a field that are based off models that we've run, indicate areas of high risk for sediment contribution to streams. And they're shaded in red here, and you can toggle it on and off to see areas that our models have indicated might be at high risk for sediment loading. And when doing screening for this project, it actually utilizes this data to determine the degree of how much a particular conservation practice might reduce sediment loading. So if you're looking to prioritize fields for conservation, this is a useful map layer to do that. And if you want more details on how that was modeled, you can click on this information icon, and there's a link for more at the bottom here after this brief explanation. And there's links to detailed metadata as to how all that data was calculated. Right. We're going to close this for now. So let's evaluate this field right here in the center for the RCPP project in which we want to calculate a score. So to do that, I'll press on the score calculator button. And it's usually best to log in to an account. If you don't have one, it's very easy to create. Just going to use a demo account that I'd set up. And you can have a number of different projects in your account, or you can create a new one. Call this demo 2, since I already have a project named demo. And the first thing it'll ask you to do is to draw a field, the field of interest. So we're going to do this field here. And I'm going to leave this part out. And as the instructions say on the screen, double click to complete the shape. And it shows the field here, 71.7 acres, and I'll click done. And next, it's going to ask me to describe the field. And to do that, I'll fill out this survey. So I click on the field survey button. And the first question we'll ask is the area I drew for a filter strip? And no. And I should say at the outset that the way the questions are structured on this survey, it's kind of like a pre and post. So we're proposing a conservation scenario, an alternative scenario. And we want to evaluate what the change would be in groundwater recharge and sediment loading. So the questions that are labeled as the 1A would be what's currently going on the field, or what the current situation is. And 1B is the proposed scenario. So is this drawn area for a filter strip? In this current situation, no, it is not a filter strip, and we're not proposing a filter strip. Same for a grass waterway. But which of the following best describes the current land cover? We'll say it's under a corn soybean rotation. And then 3B, which of the following options best describe the proposed land cover? And we'll say that we're looking at a corn soybean wheat rotation to incorporate wheat into that rotation. The current tillage, we'll say, is under conventional till, and we're proposing to implement no-till on this field to see what impact that would have on recharge and sediment loading. And does the current field rotation include cover crops? We'll say presently none, but that we want to evaluate a winter wheat scenario. And is the field tile drained? And we'll say no, and that's not going to change in our proposed scenario. A lot of the sedimentation modeling is based off of Russell, utilizes Russell to estimate soil erosion. If you're familiar with and comfortable with picking more detailed Russell parameters for your scenario, you can. Otherwise, the system will rely on default values and background data derived from different satellite imagery and soil databases to calculate that for you. But that's available as an option. So I have my answers for the survey. I'm going to click submit, and I can hit calculate, and the system will start calculating. It probably takes, for one field, it'll probably take about 45 seconds to generate a result, and it'll give me a status update here. And the outputs that it'll provide are baseline estimates of groundwater recharge volume in gallons per year. And that's what the model thinks is currently going on. And then it'll have a proposed recharge volume. The blue area that was just added to the map is what we call the contributing area. So when we're calculating a change in sediment loading, we don't just consider what happens within the field, because a certain practice is not just going to affect the soil erosion and sediment contribution on the field, but it's also going to affect sediment that travels through the field to the stream network. So when we determine how much sediment a particular practice might reduce sediment loading on a given field, we consider the entire upland drainage area to the field, not just the field itself. So the system's done and gives me my results. And I can see here that I have a change in sediment loading, jump to the bottom, based off of the practice that we specified using incorporating wheat into our rotation, using no-till and a cover crop, that we could expect a reduction of sediment loading of 21.83 tons per year. But note that groundwater recharge decreased as a result of those practices, mainly due to cover crops can have a negative impact on groundwater recharge, though they do have a significant impact on groundwater, should say on surface water quality and helping reduce sediment load. So let me view the priority scores. And I have a bunch of data here to sort through. The first things in this table that I should point out is that the system will tell me what percentage of my field is in either a recharge priority area or a sediment priority area. I can also go back to the map layers and turn that layer on, and I can see that this field of interest is all green, so I'm safely within a sediment priority area. And because of that, because more than 50% of this field was in a sediment priority area, my field, this conservation practice, is going to be evaluated in terms of its water quality impacts. And the system points that out here. It says, will implementing selected practices within this application result in a significant decrease of sediment loading? And it'll point out here, the total points are based upon sediment reduction because more than half the field was in a sediment priority catchment. And there's a range of potential scores from 0 to 250. And based off the modeled results, my particular scenario that I ran here was worth 160 points. Now, if I was in a recharge priority area, then it would be evaluating my performance based off these the groundwater recharge criteria. And in this case, since it decreased recharge, it would be deemed ineligible. Now, if I ran another scenario and changed the parameters, perhaps I didn't utilize cover crops, it would likely increase groundwater recharge. And I'd have a different result here. I might have some points that I could have earned some points for groundwater recharge, but in this case, I earned more points through on the water quality scale, the sediment priority scale, of 160 points. I'm going to save these results to my account. They'll be saved into that project I specified, Maple RCPP Demo 2. I'll call this no-till with wheat and CC for cover crop. And I'll save it. And it's been saved to my account, and I can come back and reload this anytime I come back to the system. I'll point out one other feature that might be useful if you're working on multiple fields at once. If you want to change some of those options and see what new results might be, you could click Run a New Scenario, and it'll ask you, do you want to edit the survey answers on the current field of the map to see how results might change, or do you want to start with a new field? If I click Start with a New Field, it'll ask me to draw another field. I'm going to pick this field to the west. I'll just work on that section. I'll click Done, and it'll ask me to provide some new inputs for the field survey. And if I don't want to have to specify all those same options that I did before, there is an option to import saved survey answers. So from any previous scenario you ran in your account, as long as you saved it to your account, you can import those answers for this one. So I'm going to go to my Demo 2 project that I just created, and I have the scenario I just saved. I can click Import Survey, and those same answers that I provided before are in here as well. And I'd be set to run another scenario.